similar to it, where it would be kind of a chain reaction, and that would be, let's say it's Fe2 plus. So I'm just going to do one very quickly. Fe2 plus reacting with MnO4 minus 1, and it's acidified. Uh, I have written down the ionic equation, so I don't want to go into a lot of detail. So my reactants are Fe2 plus and MnO4 minus 1. And we're going to try, and I'm going to do the working on the data booklet now. So I've got, instead of writing the equation, wasting time, I'm just going to do all the working on the data booklet. So Fe2 plus reacting with MnO4 minus 1. So where is Fe2 plus is, I've got two equations involving three equations involving Fe2 plus. So there's this equation which has Fe2 plus in it. There is this other equation which has Fe2 plus in it. And I've got MnO4 minus 1. So I've got, there's this other reaction that also involves MnO4 minus 1. Is there MnO4 minus 1 anywhere else? I don't see MnO4 minus 1 anywhere else. So out of all these reactions, and let me highlight these reactions. Okay, so out of all these reactions, what I have is the higher potential gaining electrons and the lower potential. So the highest one at the moment is 1.67, right? So that's the one that's going to gain electrons, and the lowest one is at the moment minus 0.44. But I'm not going to take that because it's in that case it's going to be Fe that would lose electrons, and so it's going to be Fe that would lose electrons. And we don't have Fe. Remember, it was a reaction between Fe2 plus and MnO4 minus 1. So I'm not going to pick this reaction. Okay, I'm not going to use this reaction. Instead, the lowest one is 0.77. That's the one I'm going to pick. It's Fe2 plus losing electrons, and I wanted a reaction for Fe2 plus. So I have figured out the one that loses electrons, and I've figured out the one that gains electrons. Okay, higher potential gains, and the lower potential loses electrons. And I would have to multiply this equation by 3. Again, that's going to give me, that will give me my, and I'm going to write this reaction at the bottom over here. So it's, yeah, the clear, Minal, Hala, Mawa, is this clear? This thing.
Yes, sir.
Okay, so I'm going to write this reaction over here below, right? I'm not going to copy things. I'm just going to be quick. 3Fe2 plus, that's one of my reactants. And in the bottom one, it's MnO4 minus 1 and 4H plus 1. And the product is, the first one is 3Fe2, Fe3 plus. And in the bottom one, the product is MnO2 plus 2H2. So those are my products. So I've got this reaction, but that's my first reaction. And let's assume again that Fe3 plus is in excess. I mean, let's say it's written that Fe3 plus is in excess. So after this first reaction, what do I have? I've got these products. I've got MnO2. I'm going to write. So these are my reactants now. I mean, the products of my first reaction. I've got MnO2. I've got Fe3 plus. And I've got, sorry, the reaction was with Fe2 plus. So let's assume that Fe2 plus was in excess. So once the first reaction happened, these are the products of the first reaction. And there's some left over, let's assume Fe2 plus. They've told us that Fe2 plus is in excess. Now what will happen? I'm going to do everything again, and I'm going to focus, will there be another reaction after this first reaction? So the first reaction has happened already. We're done with the first reaction. We are now going to focus on the second reaction. So I'm going to focus on MnO2. Where is MnO2? I've got MnO2 over here. Is there any other place? There's MnO2 over here as well. And there is, there's no MnO2 anywhere else. And then I'm going to focus on Fe2 plus and Fe3 plus. So Fe2 plus and Fe3 plus. So they're pretty much everywhere. This is Fe3 plus. So all of these things. Now, if I bring the two things together, the higher potential gains electrons. Now, if you look carefully, the highest potential at the moment is going to be 1.23. This is the one that's going to gain electrons. I'm not taking this one as the highest potential because that would mean this gains electrons, and I don't have all of this. I'm looking for a reaction of MnO2. So which is why I'm not going to look at this reaction, although I had circled it before. But since the higher potential gains electrons, uh, we don't have MnO4 minus 1. We used to have MnO4 minus 1, but now we have MnO2. Okay, so that's the equation that gains electrons. And the lower potential is the one that's going to lose electrons. So minus 0.44 is the lowest, but it's Fe that loses electrons. We don't have Fe, so I'm not going to use that. Minus 0.04 is the lowest potential. That's the one that's going to lose electrons. But again, we don't have that. We don't have Fe. Then it's 0.77. Fe2 plus is the one that loses electrons. We do have Fe2 plus over here. So I'm going to pick that one. So 0.77, that's the one that's going to lose electrons. So is this, and I'm going to highlight this. Okay, this is my oxidation equation, the one that loses electrons, and the higher potential gains electrons. So that is my reduction equation. Okay, and using those, I am going to construct my second reaction. So after the first reaction has happened, I would have to balance the electrons. So I'm going to multiply this entire equation by 2 so that 2 electrons are being gained, and so 2 electrons should be lost as well. So my second reaction is 2Fe2 plus MnO2 plus 4H plus 1. And the product is 2Fe2 plus. And in the second one, the product is Mn2 plus 2H2O. So after the first reaction has happened, we have gotten, the products of the first reaction, which are over here, have now gone on to do a further reaction, which is the second reaction. Is this clear? Hala, is this clear? Baba, Minal, is this clear?
Yes.
So you get a second reaction, right? Now, this would Fe2 plus would continue to lose electrons as long as Mn has, and let me highlight both equations now. Okay, we had this. Did we have? Yeah, we had this equation first, and then we had a reaction the second time. So what is happening is Fe2 plus was the lower potential. It kept on losing electrons. It turned MnO4 minus 1 into MnO2 because that was the higher potential. It gained electrons. Then that MnO2 further gained electrons. Why? Because it was still the higher potential compared to 0.77. And once Mn2 plus is formed, this Mn2 plus will not further gain electrons and turn into Mn. Why? Because now it's not the higher potential. It's actually a very low potential. It's not going to gain electrons compared to 0.77. So the chain reaction continues as long as this is the lower potential and it keeps losing electrons. Gains electrons, higher potential, gains electrons, higher potential, and stops there. There's no further reaction after that. Achha, is this question clear? Hala, Mawa, is this clear? Minal, is this clear?
Yes, sir.
Okay. Achha, but still, again, don't worry about these questions because these questions are, they've only been asked a couple of times ever. But chain reactions, the one that we did last time, they're all kind of difficult and confusing because you have to You have to do it a couple of times. You have to do the whole process 2, 3 times. Okay, so you can just have a look. You can just know one example, and that should be sufficient. There's a very 99% probability you're not going to get chain reactions. So we're going to jump to electrolysis now. Yeah, that's a new subtopic. Now, electrolysis you've studied in O levels. What happens in electrolysis is that, I mean, the first thing is the rule applies that the high inert is the one that gains electrons. Keep that in mind always. And the one that has a lower electrode potential is the one that always likes to lose electrons. So the same concept would just carry on. You can keep this in mind that higher potential gains, lower potential loses. Now, what is electrolysis? Now, electrolysis is kind of the opposite of a cell. In a cell, you had, like, if you look at any of the cells, you had a reaction, and that reaction produced electric current. In a cell, there is already an electric current. So you already have electrical energy passing through, and that electrical energy leads to a reaction. And it leads to a redox reaction. It forces some of the species to gain electrons, and it forces other species to lose electrons. But the energy is coming from outside. So it's an endothermic process. It doesn't produce electrical energy, it's actually consuming energy. So we're going to do one example first, which is let's do the one that you already know. I'm just going to construct 2 electrodes. Okay, so you've got okay, so we've got these 2 electrodes, and let's do the electrolysis of copper sulfate. So there's this. Okay, so we have this beaker, and the electrodes are dipped into it. And I have a battery attached to it. Now remember, even before the reaction, the current is already flowing. This is the negative cathode, and the other side, that's your positive anode. Now, electrons are already flowing. I mean, the battery is sending electrons from one side, and the battery is taking up or removing electrons from the other side. So whoever comes to the cathode, reduction is always going to happen. They would always gain electrons. I mean, they don't have a choice. Any species that comes on this side, anyone who comes on this side, the battery is going to give it electrons, and that's the only option they've got. I mean, now they don't have a choice. In the previous example, the potential decided what would happen. Now they don't have a choice. If you're at the cathode, you got only one choice, which is you're going to gain electrons, and that's it. Okay, is this thing clear? Is this clear, Mawa? Hala, is this clear?
Yes.
So at cathode, you don't have a choice. You're only going to gain electrons. And what did we learn? Who gains electrons? The one that has the higher E naught gains electrons. And and we're only going to look for reactions going in the forward direction in the data booklet. So look for reactions going in the forward direction because they're only going to gain electrons. And whoever appears to be on the gets attracted to the anode, it's the battery is going to take away electrons from it. So they don't have a choice. They're always going to lose electrons. So at the anode, only one thing will happen, and that is oxidation, and only they're always going to lose electrons. So they are always going to end up losing electrons. And who loses electrons? The one that has the lower E naught. That's the one that likes to lose electrons. And when you're looking for reactions, look for reactions in the data booklet in the backward directions. So I'm going to give you an example, which is that, and that would make things clearer, and that is, okay, let's say you've got copper sulfate aqueous, right? So let's say you've got copper sulfate aqueous. So how many species do you have in this? You've got copper ions. If you know O levels electrolysis, positive ions are going to get attracted to they're going to get attracted to cathode. And you've got sulfate ions, which are negative ions, and they're going to get attracted to anode. And since it's aqueous, there's going to be, oh, I mean, if it's aqueous, there's going to be water. And water is a neutral compound, so water appears on both sides. Now, one thing that we're going to assume is that in O levels you did H plus one and OH ions. So one other thing that we're going to state is that although you can still use H plus one and OH ions, you can still get away with it. But technically, you remember that water doesn't really ionize a lot. Water very weakly ionizes. So almost, there is no H plus one or OH ions. I mean, if you write H plus one and OH ions, it's still pretty acceptable. But technically, water doesn't really have H plus one or OH ions. There's very little H plus one and OH ions. So, so the thing is that there's not much of H plus one and OH ions, so you don't have to worry about H plus one and OH ions. You can just write water, aqueous, water as water, and you have to put them on both sides because water is neutral, so it can go to the cathode. It can also go to it's actually everywhere. Water is like everywhere. I mean, most of the solution is water. अच्छा यहाँ तक is this clear up till this point? Hara, is this clear? Mama, Minil, Roshi, is this clear?
Yes.
I said now the next thing is what I'm going to try and do is I'm going to look for. Remember what happens at cathode? Someone gains electrons, right? So I have to look for equations. I've got two options. It's either going to be copper plus two gaining electrons, it's either going to be water gaining electrons. And remember, I'm only going to look for the equation where they're gaining electrons because only one thing happens and that's reduction. So I'm not going to look for reactions where they're losing electrons. I'm only interested in reactions where they're gaining electrons. So copper plus 2 and H2. I'm going to look in the data booklet. ठीक है इस सारे को मिटाओ जरा एक सेकेंड तो ये क्या अच्छा so getting rid of all of this. So remember copper plus 2 and H2. So can you spot copper plus 2? There is, and remember copper plus 2 gaining electrons. So only look for the equation in the forward direction. So here's one, copper plus 2, and here's another one, right? So copper plus 2 can, so I'm not interested in the reversible sign because the reaction, I mean, it's not going to go back and forth. There's only one option, and that is the gain of electrons. So I've got two options, 0.34 and 0.15. And there's water as well, so I have to look for water gaining electrons as well. So I'm going to look for water. Up here, water. Do you see water anywhere? Water gaining electrons. पीछे था एक second. Yep, it's over here. So I've got water gaining electrons. That's just 1 second. My tab disconnected. Just one second. फिर कौन सा था एक सेकेंड अच्छा we were at this point. अच्छा again copper 2 plus याद clear था copper plus 2 I had copper plus 2 gaining electrons, so it could gain 2 electrons, it would gain 1 electron, right? Only look for equations in the forward direction where they're gaining electrons. I've got water which is also gaining electrons, so only look for equation in the forward direction, water gaining electrons, right? So I've got three things competing for those electrons. You can have a look at the diagram again. So if you have a look at the diagram again, it's copper plus 2 gaining electrons or water gaining electrons. And who gains electrons? The one that has the high E naught. So I'm just going to look at the data booklet and I'm going to find out which one has the high E naught. So the high E naught in this case, which one has the high E naught? I think it's this one is minus 0.83. The other one is 0.15 and the first one is 0.34. So that's the highest one. So that has the greatest tendency to actually gain electrons, and I'm going to go for that. So out of all of these equations, it's actually copper plus 2 that ends up gaining electrons. And the E naught for this is 0.34 volts. Is this clear?
Yes, sir.
बाकी में से वो notes के लेना, I'm just writing them down very quickly. 1 second. Copper plus 2 plus 1 electron. We rejected it because it was 0.15 volts, although that is also copper plus 2 gaining, but 1 electron. And then I had the third one, which was water, 2H2O, gaining 2 electrons, and it was forming, I think it was forming H2. Kya form kar raha tha? So that one was forming H2 plus 2 OH ions. And the E naught for that was minus 0.83 volts. So we went for the first one. Okay. Now for the other one, we will do exactly the same. For the other one, we'll do exactly the same. So it's going to be one of these two losing electrons, right? So it's either water losing electrons or sulfate losing electrons. They have to lose electrons, right? So, and who loses electrons? The one that has the lowest E naught. So we're going to look for reactions in the backward direction. So sulfate and H2O, they must be on the right side because we want them to lose electrons, not gain electrons. Okay, so we're not going to look for equations in the forward direction. Okay, that's not what we're going to do. So if we have a look, so यहाँ पे I've got two equations for water. And there's one equation for SO4 minus 2 as well. एक सेकंड स्क्रीन पे just a second. वैसे डेटा बुकलेट के साथ कोई इशू है वो जो आगे स्क्रीन वापस So here's the data booklet. I said two equations for water losing electrons, which I found out over here. You can remember, this is one where water is losing electrons backward. Here's another one, water losing electrons backward, right? So I've got two equations of water losing electrons, and there's another equation for sulfate losing electrons, which is over here. So I've got an equation for sulfate losing electrons. There are other equations that have water in it, but it's water reacting with lead. I don't have lead, so I'm not going to pick that equation. So I'm only going to pick those equations where either it's water losing electrons or whether it's sulfate losing electrons. So I'm not going to pick any equation that has water in it. So I've got these three options. And who has the greatest tendency to actually lose electrons? The ones that lose electrons are the ones that are the lowest potential. So I've got 1.77, I've got 1.23, and this is pretty high, that's 2.01. So the one who likes to lose electrons, it's the lowest potential, it's coming out to be 1.23 volts. Okay, is this clear? Okay, this is the one that I'm going to pick up. Okay, is this clear?
Yes, sir.
So यहाँ पे out of all the options between water and sulfate, it came down to water losing electrons, and वो equation क्या थी आपको? Water था, and it lost electrons. You can remember I'm writing the equation in the backward direction, but I've actually sort of straightened it up. Okay, so I've got water losing electrons, and it was forming O2 plus 4H plus 1 plus 4 electrons, and the E naught value for this was 1.23 volts. And the other two equations, I'm going to just write the other two equations as well. There was two water and H2O2 plus 2H plus 1 plus 2 electrons. And this was 1.77 volts. And there was a third one for sulfate, which was SO4 minus 2. And क्या बना रहा था वो S2O2 minus and 2 electrons lost. And this was 2.01 volts. So I picked the equation that had the lowest potential because that's the one that really likes to lose electrons. So that's the electrolysis of copper sulfate, which now is way more complicated. When you studied it in O levels, that was pretty easy. But now using it's not that complicated. All you have to do is just open the data booklet, find out your species, who's gaining electrons. Only look for equations where these things are gaining electrons, and just select the equation that has the highest potential when it comes to gaining electrons, which came out to be this one. On the other side, anode, you're going to look for reactions where they're losing electrons. Look for reactions in the backward direction, where these things are losing electrons. And who likes to lose electrons? The one that has the lowest potential out of the three. Okay, and that's it. Is this example clear?
Yes, sir.
Yes.
So I'm going to do another one. Okay, let's do the electrolysis of NaCl. Okay, let me. So let's do the electrolysis of NaCl. I'm not going to copy the equations. I'm just going to do all the working on the. कुछ ज़्यादा time copying में लग रहा है. I'm just going to do all the working on the data booklet. Let me get rid of all of this. Okay, the rest is fine. I've got NaCl aqueous. What do I have? At the cathode, I've got Na plus 1. At the anode, I've got Cl minus 1 and H plus 1 and not H plus 1 and OHN. वो तो मना किया था. There's no H plus 1, there's no OHN. I'm going to put water on both sides. Okay, and there is water on this side as well. So I've got water on both sides. So who gains electrons? Is it Na plus 1 or is it going to be H2O that that gain electrons. So we're going to just do that all our working on the data booklet. Remember the higher potential gains electrons. So Na plus 1 H2O, look for the equation in the backward direction, forward direction. So get rid of all of this. And getting rid of the previous working. So I've got Na plus 1 gaining electrons. That's minus 2.7. That's a very low potential. That means it never really likes to gain electrons. And I've got water gaining electrons. So water was over there in Quakey frame. Okay, so water is at the top gaining electrons, N is at the bottom gaining electrons. So two reactions, minus 0.83 and minus 2.71. So who likes to gain electrons? The one that has the higher potential, which is going to be the water equation over here. Is this clear? Okay, water is the one that's going to gain electrons. You clear?
Yes.
Yes, sir.
So यहाँ पे now what we'll do is, I'm just going to write that equation 2H2O plus 2 electrons. Then I guess it was what, H2 plus, I think 2H minus 1, and the E naught for this was minus 0.83 volts. And it ended up water gaining electrons, and it didn't do anything. And it had a very low potential, which means that it never really wanted to gain electrons. So on the other side, I've got two species, and they want to lose electrons. So it's either water that loses electrons, or it's Cl minus 1 that gives the electron to the battery. So out of these two, I have to decide who loses electrons. Is it water, or is it Cl minus 1? Who loses electrons? So go back to the data booklet, find out water and Cl minus 1. Now you're going to look for the equation in the backward direction. You want them to lose electrons. The one got the water tha and Cl minus 1, right? So Cl minus 1 is somewhere over here, losing electrons. I'm going to ignore this one because it's got Cl minus 1 with OH ions. I don't have that. So we're just not going to use that. That's a Cl minus 1 losing electrons. That's 1.36 volts. Compared to what? Compared to water, right? Water losing electrons. So we look for water losing electrons again in the backward direction. So water losing electrons, lost electrons. So it's 1.77. This is 1.23. And Cl was 1.36. Remember that. So who loses electrons? The one that has the lowest potential, which is water in this case. Remember, Cl minus 1 was Cl minus 1 losing electrons was 1.36. So that was so you had 1.36, you had 1.23, and you had 1.77, right? So out of all these three, water wins. Water is the one that has the lowest potential, and that's the one that's got the highest tendency to actually lose electrons. So over here, it's water that also loses electrons. And when it loses electrons, what do we get? We get water losing electrons. We got O2 plus 4H plus 1. And the E naught for this was 1.23 volts. Okay, is this clear? Clear? Is this thing clear? Bhava, Hala, Minal, is this clear?
Yes.
Yes, sir.
So that's basically what electrolysis is. And you can do electrolysis of pretty much anything. And you can also include they would ask a question, uh, why does concentrated NaCl produce chlorine at the anode? So remember, there was a competition happening at anode between water and Cl minus 1 losing electrons, right? And they had potential. So water equation was already written for us, right? I mean, there was already a water equation, and it was losing electrons, and it was forming O2 plus 4H plus 1 plus. And the E naught for that was 1.23 volts. For Cl, the equation of Cl losing electrons was that the Cl lost electrons and it formed Cl2 plus 2 electrons. And it was 1.36 volts. Now remember that the lower potential is the one that loses electrons. Okay, the lower potential is the one that loses electrons, which is this one. I said, like, why does concentrated Cl change the potential? Now, remember, in all these equilibrium reactions we studied earlier, that if you have a higher concentration of Cl ions, right? So if you have higher concentration of Cl, where would the electrode equilibrium shift? It's going to shift forward, right? Ye clear hai? Middle clear hai? Mahava, Hala, is this clear? That a higher concentration would push the Cl minus 1 towards the right, and more electrons are going to be produced. And when more electrons get produced, the potential would decrease. So maybe it becomes 1.15 volts. So I'm going to write all of this down, that higher concentration pushes the electrode equilibrium what electrode equilibrium? It was Cl2 and Cl minus 1 to the side which produces more electrons. And what does that do? And that, because more electrons are getting produced, it decreases the electrode potential. The electrode potential becomes lower than the standard potential. So if it becomes 1.15, then Cl minus 1 is the lower potential. And then it's Cl minus 1 that actually. So when the Cl2 Cl minus 1 electrode decreases below 1.23 volts, which is the water potential, then it is discharged. Okay, is this thing clear? But this last thing, is this thing clear? Okay, although water is the one that has the lower potential, but if you increase the concentration of Cl ions, the equilibrium in this electrode will shift to the right. Because higher concentration, it will try to decrease concentration. More electrons will get produced. And if you have more electrons on the electrode, your potential would decrease, right? It's instead of 1.36, it would be 1.15. So relatively speaking, it's actually the lower one now. And therefore, at higher concentrations, you actually get chlorine gas. Okay, Hala, Mawa, is this clear? Minal, is this clear?
Yes.
So, चलो let's continue next time. We'll do some more electrolysis questions. और उसके बाद we'll do past papers, ठीक है? Okay, Allah Hafiz.